Hello, welcome to Plutus Project-Based Learning 2023. Today is September 9th, and I'm recording this video about the usage, writing and using Plutus validators, module 301. And we are today on module 301.3, which is understanding how the datum is used in Plutus validators. First, we'll talk about the role of the validator of the datum. In Plutus, the datum is used to hold data. This data can serve as reference. Basically, you will have saved some data type which allows you to validate your script, but other smart contract may also access this data and validate their own transactions. The value, however, is checked by the validator regardless of what you do. First of all, because it's going to check whether you have the same value, especially if it's hashed. The validator will tell you whether you have the wrong or correct value. If you see it, then it's not necessary to provide it. If it's inline, you can basically indicate in your logic. We'll see that in the example we'll be doing, that the datum is inline, it's visible. You just need to tell the validator that it is present at your script address. The validator syntax is still, as I had mentioned in the previous content about Haskell, is we use the form of the validator. Sometimes we put in parameters. We'll see in the smart contract model we use today, we will have parameters. However, that parameter will be used only for the sake of creating the address. We won't be touching on the parameters, the datum, and then the redeemer, and then the script context. And whenever we have the datum, redeemer, and script context checked, meaning in the first example, it could be either a true value, whether we put conditions. If we do not put conditions, which is in this case here, we're not checking any of these three elements, then the value will be true, which means it's going to always be succeeding. If we put true, if we put false, it's going to be failing. And depending on whether we use the datum and the context, it may or may not be true. Okay, so basically that will depend on the logic that we are using by using those two values. The same if we use the redeemer and we ignore the datum, but then we will still use the context, it may or may not be true, may or may not succeed. So there are two types of format, as I mentioned. The one is stored by its hash, and the other one is inline. The hash will be computed by the sender before interacting with the smart contract. The hash value may not be known using your eyes. You may not know it by looking at the UTXO. However, it's not cannot be considered like a way of saving your funds or safeguarding your funds, because there are ways that people can come and get the value of that hash. It can also be inline. In the inline datum, in this case, is publicly visible. You can read it by just looking at the UTXO. There are benefits and downsides to that, but I would say mostly by experience there is more benefit than downside, because there's many other ways you can use to safeguard your funds on the script. Earlier, when we were learning on how to use smart contract, the hash value was the default value, and we kind of took liberty to take it as some type of secret password. You can lock your funds using your hash. However, as the validation process got developed and updated, then with the inline datum, there is no such a secret. Now we kind of have to go through other means to safeguard the funds, and it's not advised to use the datum as a means to safeguard your funds. There are better ways to do that. So we'll look at those in future lectures, but for the moment we're going to use the datum. So what can serve as a datum? It's an arbitrary form of data. You can use whichever type of data you want. You could make it complex, you can make it very simple. It can be a value. In this case, we'll use the value given the smart contract we are using. It can be a string, even if it's a value, or a number. In this case, we are having an integer. I'll show you why we need an integer. And it can also be a data definition, which means a series of variables with the values. and any other type you may create to check your validation of your functions, of your function definition. So by checking the value of the datum, you can inspect it on the Cardano Explorer. You can basically look at the transaction, see the UTXO, inspect the value of the datum, you will see how it looks like. When you're accessing the Cardano CLI using an inline datum, the value will be observable from the UTXO, as we'll see, and some other examples. There is nothing preventing you from saving data using a datum. However, when you are trying to retrieve those funds, there will still be condition on the parameters of your validator. So you may send funds and be unable to retrieve them if you do not respect the type of your datum. So in our case, we'll be looking at the starter template, which I'll show, which you'll see, have seen the link in the module description, and I will also show you right away where to find this template. And as you can see, we have defined the type for the starter datum, which is an integer, and the starter action, which is also an integer, as I showed in the previous lecture 301.2 for Haskell. And now we'll continue and we'll later learn about the redeemer, but for the moment, let's go in and do our example. So in order to get to the starter template, you basically come at this link. It's PBL 2023, PBL Plutus starter 2023, and in it you will see a starter folder which has a validator script. Okay, this you saw it in the previous lecture, which is at 301.2, and you will have seen importing some dependencies, defining your module name, importing other modules, and then putting in the logic. In this case, there is no condition. We are naming those variables, but the result will always be true, so which means it's an always succeed type, and that's what we'll be practicing today. So how do you come from your download? So once you clone this repo, in case you don't know, come here. This is the root of the repo. You clone it through SSH or HTTPS. So I've cloned it already. So after you have cloned it, in order to get your smart contract address, which will be in the output when you download, you'll see it here, but I'll make sure to kind of delete it and recreate it for your own benefit, for you to exercise your creation of a Plutus script. Okay, so in my case, I'm here. Once you have downloaded your cloned PBL starter, you have to go into the Nix shell through the Plutus apps. I hope you have practiced. In this case, you download the Plutus apps from the Cardano GitHub repo, and then you basically launch Nix. You need to put in the experimental Flake extension, but however I've set it as a default, so by typing the Nix shell it should be correct. So Nix will start, and once you have Nix getting ready, I'll go ahead and delete my output folder for the starter, which is this one here. Okay, let me see. Okay, so let me delete it, and then we'll go ahead and create it again. Okay, so Nix has been ready. Now I will go ahead and navigate to my Canva Labs folder. PBL Plutus starter, and then what I'll do the cabal repo. Okay, as you had seen in the previous lecture, the compiler is contributor token compiler is the default one. However, I'll have to load the starter compiler. So which means I will have to basically load the starter, which is let me see how the design is. So we need this one. We have been in this contribute token. Now we need to go into the starter. So in this case, what you do, you load the starter dot validator, no compiler. Okay, so I need the compiler. Okay, so in this case, you can see how it looks like. So we need this compiler here and the validator, which I'll be covering shortly. However, we need to load this compiler. And to do that, as I had shown you in the previous lecture, what we do double column L load starter compiler. Okay, starter compiler. Okay, so we have access to the compiler, and what we need is to basically run this starter script, okay, which is going to create the PBL starter validator. Remember, in my output, I do not have that file. I've just deleted it. You see, there are only two files. So now what I will need is to run the validator. However, we're going to look at the functions which I had showed previously. This is the validator function. This is boilerplate. These are default templates for most Cardano Plutus script. You'll have to need this that supporting basically elements of the Plutus validator. However, the main validation happens here, and that's where you basically will be using whichever dependencies you have imported. This is also mostly by default. Overloaded strings means you have defined your parameter types, as I've said in the previous lecture, and some other dependencies you import, as well as other modules you may use. We may use the Plutus context, the API, and some validator modules to use many of the functions we're using here. Okay, so once we have the compiler, what we need is to go ahead and run this function myself. Okay, so as it runs, you'll see here it's right, so it's succeeded, so which means this has just been created. So once this one has been created, I need to go here and copy this file. So we have now our Plutus validator. I don't need this repo again. I can quit it, double colon Q, and then I can also exit the next shell. Okay, and then from it I can go ahead and look into the folders want. As you can see in the output, I have my Plutus validator, which has just been copied at 8 p.m. So I can copy this one and go and paste it into a working directory. The working directory I'll be using is this one, Gimbal Plutus, which I again paste that Plutus file, and from here I can now go ahead. I need this file so that I can basically have my payment keys. I have two addresses, and I had done some transactions, but basically you need a working folder where you'll be having your Datum file, your payment keys, and also some protocol parameters, but I'll tell you why we need those and when we need those. So from here I can go and basically either I can come from this and navigate to the folder, I can close this terminal and just open it from here. Okay. So how do? We have a Plutus script. Now we need the Plutus address for the smart contract. For that, I have a series of commands I prepared. So I'll be using this one. First of all, I need to tell my command line what is testnet. Let me get this. So testnet will be okay. So this is a kind of a shortcut or a local variable I use. Basically, use testnet preprod and refer to it as testnet only. Okay, so testnet is referring to testnet magic 1, which is testnet preprod. And now I can launch my command. This is going to create an address using the PBL starter validator.plutus script. Okay. Okay, so paste. See that file has just been created, this guy here. Okay, it has just been created, and using it we can now go and look into how to see the transactions. Okay, so I'm going to do a transaction which consists in sending some ADA. First of all, I'll have to basically get some again variables to use, shortcut variables like this Plutus script in use will be the PBL starter validator Plutus. The address, the smart contract address will be the file we just created. I'll be sending 50 ADA and I'll be using my payment one address, which is I don't even have the payment one address. I'm going to use this payment address without the one. Okay, so use this one. So these are the commands I'll be launching in order for me to have access to my smart contract. Also, will be using those variables to basically make my job easier. Okay, so I'll copy all of this and I can basically launch the commands. Okay, so now I need to find UTXOs to use for my transaction. I will be looking into how many what UTXOs I'll be using. Let me make this one bigger. Didn't write that, but I know how to write CLI query UTXO. I need an address. In this case, the address 1, and then I'll be looking at the testnet. Okay, so this is the UTXO list I have, and I'll just be picking one which has more than 50 header. This one has more than 50 header. Index 1. So it's still index 1, so I just need 1. I don't need 2. And I've already set my output to 550 header, so which is okay. I'll run this one first. And while we're at it, let me also inquire the value at the smart contract. As I said, I had done some transactions to show you, but the goal is not to show you now the transaction, is to show you what the UTXO is holding as we speak. So the smart contract is holding two values, 50 header, which was sent with a datum of inline, which shows you that you can basically read the values of the datum. In this case is an integer and a text, okay, some bytes, which is said open. Usually you will be able to see a hash. Now you can actually read the status. In this case, if it's your logic to look at something which is open or closed, you could do that through your datum. And this is just another constructor with a number which is of the type number integer 35, However, these two types are not meant to succeed in retrieving them because they are not of the integer type. Okay, I'll show you why we need the integer type. We need the integer type because in our types, when we created the starter datum integer, we set it to be an integer. Okay, so basically in the validator, the starter datum is of type integer. You cannot use any other built-in data or some other type. No, you need an integer. So in this case, it's going to be simple. We'll have two cases, a value of an integer or if a hash of an integer. Okay, so let's start with the value of the integer. I don't know which one we'll be starting with. So this one I've sent it. Now I'm going to basically, let's put a value, okay? Let's put a value. So we have address 1 sending 50 ADA. In this case is still as output. And then the value gets a number. Let's see what is the clock now. 17. Okay, so let's change the value. It's 17, so I'm going to put here 17. Just show you that I can change this on the go, and it's going to be September 9. I'll end with a 7 here. Okay, just changing these values quickly. So everything seems okay. So there's a value of 17, and I'm going to get this draft file. Okay. The Lovelace cost is estimated. I can now sign it. And then submit it. Okay, while it's being submitted, we sent it using an inline value. Now we're going to use a datum hash. Okay, so we'll still use the same value of 17. And then we'll use add. The transaction is still being processed. If you want, we can look at whether it has already been posted. It should be. Yeah, so we have the 50 ADA with a value of 17. Okay, so we know that this is an integer, direct integer. Maybe like this is better so that you see the difference between this one. You can see this one looks like an integer type. However, it's not because it comes with a constructor, whereas this one is just the integer itself. Okay, so that's the difference. Okay, so now let's see how we can send the hash. There's a command here. I'm going to hash a number, which is 17. And then I'll echo the value of that 17. As I said in the presentation, the sender needs to know what value they have used. This hash, I need it, so I copy it. And I'll put it into my transaction. Okay, so now I'm going to still use, okay, so instead of 50, you know what, I'll still send 50 ADA. And we look into a UTXO for this transaction. That's why I need another UTXO. So let's see again what UTXOs are on payment 1. I need to is on address 1, I mean. Something which is more than 50 header, this will do with index 2. And index 2 is here. Up now, I'm not going too fast, so we're going to send these 2 commands. You know what, let me send 17 header. Let me send 17 header. Okay, so which is 17 million Lovelace. Copy. And just to remind you, I have my node running, so you need, of course, if you want to use Cardano CLI, you have to have your node running. And if I look in the synchronization, I'm fully synchronized, so I can send my transaction. Okay, so it's running in the background. So let's continue. I have the value address 1 tx in 2, that's the variable here. Output 3, yeah, 17, and it's still at the smart contract address, and there's a hash of this value, and then hashed transaction hash with a 7 here to be sure that I'm not going to send the wrong. Okay, so everything seems okay. Okay, so now I can submit it. Then I signed it, now I can submit it. Okay, successfully submitted. Now we can look at the smart contract address, and we will see those 2 transactions, and then we'll try and retrieve them using the Datum value. Okay, so we see it has already been posted. 17 ADA, 50 ADA. Okay, 50 ADA with the integer 17 ADA with the value unknown. It's not unknown, of course, because we know we are the ones who sent it. We know the value of this hash is 17. Okay, however, if we didn't know, then we would not have known, but we know it, so it's 17. This value here is actually equal to this value here. Okay, however, what you'll notice is that in order to retrieve this value here, I will not need to specify it. I'll just say it is there, just use it. Okay, so just a reminder, going back to the smart contract, we're going to try and retrieve the 50 header. However, before we do so, we need to go back to the basic of the validation, and in our case we have 2 conditions to satisfy. The datum has to be of a certain type. It has to be an integer. We know it's an integer because we sent an integer. However, we also need the redeemer to be a type, an integer. Okay, so we're going to have to need 2 integers, both for the datum and the redeemer, and we will only need it both case for the redeemer. However, for the datum, if it's inline, we do not need to specify it. So regardless of its type, we're not going to send any datum anyway. So okay, so why don't we need to send the value of the datum when it's inline? Because there is nothing secret about this guy. Okay, so we know it's only a number of 17, so why bother? We just need to tell the validator the datum is inline, so we can read it, we can see it. So there's nothing to tell you that you cannot check, and there's nothing to check that you cannot see. So just know it's inline, it's available, it's visible. And for that we need a comment First of all, we're going to the second address. And before, however, before you redeem your value at a smart contract, you need two things. First of all, you need to get the correct protocols values. Okay, so parameters may have changed on the blockchain, uh, fees may have increased. The same way when you interact with a smart contract using your wallet, you may see you need to set a collateral, and as well when you interact with the CLI, you also need to kind of have the correct protocol parameters. Okay, so this one I have already gotten the most recent one, but just in case it changed a few minutes ago, I'm creating the same file. Okay, so I need the file to get the most recent protocol, and that protocol will be based on the testnet version I'm using. Okay, in this case pre-prod. So we need a second address, which is address true to, and that's the one we'll be using to retrieve. Okay, and now I need Cardano CLI, TXO address, in this case is address 2. Boom, 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 with the testnet. Going faster. Okay, so I need something to pay. This is going to be a collateral. I won't change this one. I'll just use this one for 5 ADA. This one will more than pay the fees. Okay, so I'm going to use this one with value 0, with index 0. So I'm going to use okay, and the smart contract I'm going to, this is okay, so these are just names. This is the collateral, this is the transaction to pay the fee, and this is the contract address UTXO. So I have to find that one also. I had already seen it. It didn't go anywhere, so I should be able to kind of go back. I'm going to first take the one with the inline one. Okay, copy, it's index 0. So these three variables I can basically go ahead and set them. Okay, so I'm going to retrieve funds at this UTXO, and I'm going, it's inline. Okay, so let's go build testnet. Yes, I pay the fee, I set my collateral, I use this transaction, I use the Plutus script in use, which is this one here. We set it earlier, but just in case I've forgotten. Okay, that's what we'll be using. We can just write the Plutus file itself. However, so where are we? Okay, so we're going to say that it's inline. Okay, we're here. So the Plutus script can use that one. Okay, so this is the Datum file int. This is when we use a file. I'm going to look when it's inline. Okay, so when it's inline, we are using this one. Okay, so we are going to use the redeemer. It doesn't matter. I can put we just need an integer, right? So we can put 17 here. So we are using we're consuming txc1 using this Pluto script. We are also saying that the tx in datum is present. We're not specifying the value of the datum. Tx in redeemer value 17. Using this to pay for the fees, using that for the collateral, and then the change address will be changed to address 2 for the change address for the change, and then the parameter of the protocol, and we're using this, and I'm again going to change into 7 so that I do not wrongly use the wrong file. Okay, so there's been a few changes using this is deprecated, however, so you may not need this. However, I can still use it, it won't hurt. Okay, so now we need to sign the transaction. We're signing with our second wallet address key. Sign it. Now we submit the transaction. You can see that it's successfully submitted, and I did not have in this transaction here, I did not need to specify anything about the datum value. I just needed to say that it is present. Okay, basically I can read it, there's no secret about it. Now let's go back to see what is the smart contract address. Just like any address, Cardano CLI query UTXO, which address? The smart contract address. And let's forget not the testnet. Okie dokie, good. So we can see that 50 ADA, which had a 17 number, okay, has been consumed. There were 4 UTXOs. This one here, now there are only 3. Okay, so now let's go and consume the one with the hash, this guy here. So let's go and take the value, copy, same process. What is the extension? Index 0. Consume this one. The collateral is the same, however the fee payment address, I need to find a new one given that I used the other one. So same command, however I just need to change the address to something to pay. I can use this one again, index 2. As you can see, the collateral was not used, so which means that I can reuse this one, 213A, as the collateral. Okay, let's go ahead, and the value of address 2 is still known, so we don't need to pass it again. Actually, the collateral is also still known, so but now we need to change the logic. We need to basically the Datum file. There is no file. Okay, so now we need change this. Everything looks okay. The only place I will have here is, instead of a file, I need a value of how much again? 17. Let's see. Oh yeah, it's hashed. So we'll need, it's 17. I know it's 17. Okay, that's what we did. That's what we did here. It's 17. Okay, so we need a value of 17. This is here, but even for the redeemer, we don't use a file, we use a value. And you know what? Now I'm even going to put 65. It doesn't actually matter because the redeemer, we only need it to be an integer. Okay, so what time is it? 35. Okay, so let's change that to 35. No, instead of 65, I'll put it 35 just to show you that actually anything will work as long as it's an integer. Change to address 2, protocol again are there, and then I'm going to put 17. 17, 17, and here 17. Okay, so both are correct. I hope you get it, that the redeemer, it just needs to be an integer regardless of the value. It's not it's not validated, it's not checked. However, the datum value, it is checked because that's what we're going to try and and retrieve, right? Okay, so still the same warning, not an error per se. Signing this transaction. And submitting the transaction. Okay, so successfully submitted. Now we go back to Cardano CLI, query UTXO, address, which address? The smart contract address, which network? Our testnet, which is testnet magic one. Okie dokie, query Cardano CLI, query address, smart contract, testnet. Perfect. No, it's just an error. So we have only these two remaining, and you know why they cannot be retrieved? Because these datum are not of the type integer. Okay, these are not of the type integer. This is still an inline type of datum. You can know what this is. It's two values. One is a number, it's an integer, and the other one is a byte text which says open, and the other one is just the integer itself. Okay, so however, it's an integer, it's a file with a constructor, so it's not just the integer, it's a more complex type. Perfect, so that's what we'll be doing with the next lecture on the redeemer. Instead of relying on this type for the redeemer, no, sorry, wrong file here. Where's my, okay, so instead of relying on the start action, which is in our validator, the redeemer, instead of relying on the type integer, we'll try and rely on another type built-in data, which will allow us to basically interact with the conditional flow of the smart contract. And that's what lesson 301.4 will be about the redeemer. So thank you very much, and I hope to see you in the next lecture, which I'll be recording tomorrow.